Hello everyone, this is Amit. I welcome you all in the video lecture series of the subject Operation Research. This is our 6th lecture related to the chapter Transportation Problem, in which we will study about variants in transportation problem. So let us begin our discussion with the topic variants in transportation problem. So in this particular lecture we will study about unbalanced transportation problem. So in our previous video lectures we had studied about balanced transportation problem. Balanced transportation problem means the problem in which the supply capacity and the demand were both equal. But now in this case, unbalanced transportation problem, you can see in daily life or in real life problems, it may not be necessary that availability should be equal to the total demand. So in such cases where the supply and demand are not equal, such problems are called unbalanced transportation problem. This is the general form. SI stands for supply capacity of factory and DJ stands for demand of the destination points. So these both are not equal. So such types of problems are called unbalanced transportation problem. So feasible solution was only obtained for the balance problem. Feasible solution was only obtained for the balance problem, or it can only exist for the balance problem. So if you are having on hand the unbalanced transportation problem, then the first thing that one needs to do is to convert that unbalanced transportation problem into a balanced problem. So what is the procedure for that? We will see in this particular slide. See, if the capacity is more than the demand, if the capacity of the factories are more than the demand of the destination points or warehouse, then to make it as a balanced problem we need to add a dummy column. We need to add a dummy column, and cost of shipping to these destinations are set equal to 0. So if the total capacity is more than the demand, then to convert that problem into a balanced problem one needs to add a dummy column, and the values of all the cells will be set equal to 0. So these costs are treated as real cost cells and the problem is solved as balanced problem. So all the cells that are there in that dummy column, we will assign the value of 0 to all the cells in that dummy column. Similarly, if the demand is more than the capacity, then we will add dummy row, and all the cells within that dummy row will be assigned 0 value, and accordingly the problem will be made a balanced problem. So this is all about unbalanced transportation problem. So what is your first task? Your first task will be to convert that unbalanced transportation problem into a balanced problem, depending on the situation or depending on the case, whether the demand is higher or whether the supply capacity is higher. Accordingly you will have to make the adjustment and you will have to convert the problem into a balanced problem. So moving to the next slide, we will go through one example for your better understanding, to have more clear idea how these problems are solved. So this is the same thing which I have written over here. Now moving towards an example. The example is given to you. A product is produced by 4 factories. So there are 4 factories, A, B, C and D. These production factories are having capacity of A is 50, for B it is 70, for C it is 30, for D it is 50. These factories supplies the product to the 4 stores. So there are 4 stores and 4 factories. Demand of the stores are given. For store 1 it is 25, for store 2 it is 35, for store 3 it is 105, and store 4 it is 20 units respectively. Determine the transportation cost. So this is the table that is created, or this will be given in the data. You can make, because here the data is given in this form, so I am making that, converting that into the table form, so you can find the demand of each stores at the end of the column. First column it is 25, third, fourth it is over here. Similarly factory capacities are at the end of each rows. For A it is 50, B it is 70, for C it is 30, and for D it is 50. So now if you make the summation of the capacities of all the factories, then it will give you 50 plus 50, 100, it is 200, and demand is 100 and 85. So what now? As you can see, the problem is unbalanced because here the demand is less than the capacity, or capacity is higher than the demand. So as per our discussion in our first slide, what we need to do, if the capacity is higher than the demand, here the capacity is 200 and the demand is 185. So we are adding now dummy column to make this problem as a balanced problem. Moving to our next slide. So check the problem whether it is balanced or unbalanced. So this problem is an unbalanced problem because the supply capacity is not equal to the demand. Here the production capacity is 200 and total demand is 185. So we are having surplus capacity of 15. So to make this problem a balanced problem, we will add dummy column named D. We are giving that name as a D, and all the associated cost coefficients are taken as 0. So all the cells will have cost coefficient with 0 value, and we are keeping that demand of that particular dummy column is equal to 15 because there is a surplus capacity of 15. So this is now the balanced problem. So now the problem is balanced, and now we will try to obtain the basic feasible solution. So using warm method, we have obtained over here. Why warm method is preferred? Because warm method is more preferable because it will give you the solution, or it will take you more closer to obtain the optimal solution as compared to other two methods. Warm method is a bit lengthy process, but our ultimate aim is to find the total transportation cost, minimum total transportation cost. And if you find the basic feasible solution using other two methods, and it will give you higher cost, but in case of warm method it will always give you low cost as compared to other two methods. So this is the procedure using warm method. This is the main table that I have written. Now our task will be to find the row penalties and column penalties. So how to find the row penalties and column penalties, that I will explain. See, now these are the elements in that particular A row: 4, 6, 8, 13 and 0. So taking the difference between the two smallest value in that particular row. So in this A row, the smallest element is 0, second smallest to 0 is 4. So taking the difference of 4 and 0, that is 4. So that is what I have obtained. Similarly for this, the smallest is 0 and 8. So difference between that is 8. So I have taken this row penalty is equal to 8. Similarly for this row C, similarly for this row D. Now for the column, same procedure is followed. There are 4 elements, 1, 2, 3 and 4. The smallest element is 4 and the second smallest element other than 4 is 9. So difference between 9 and 4, that will give you 5. Similarly for this second column, the smallest element is 4 and the second smallest other than 4 is 6. So difference between 6 and 4 will give you 2. Similarly for this third column, it will be 2. For 4, that will be 0, and for this also it will be 0. Now where to do the allocation? That may be a question. As I have already explained in our previous videos of the Vogel's approximation method, but again I am repeating it. Okay, how to do the allocation? So the penalties with the largest value, that row or column will be selected for doing the allocation. So you can see here there is a tie among the penalties. In this second row the penalty is 8, and in this fourth row also it is 8. So to select which row for doing the allocation, now that is the question. So in both the row penalty, you can assign in the smallest element, in both the rows the smallest element is 0, and in this also it is 0. So for example, I am selecting this. So the allocation will be done in the lowest cost cell among that row. So in row B, the lowest cost cell among 13, 11, 10, 8 and 0 is 0. So I will do the allocation over here. Now how to do the allocation? So you can see the demand of D store is 15 and the supply capacity is 70. So allocating minimum from that to 15 and 70, the minimum value is 15. So from 70 and 15, the minimum value is allocated over here. So you can see now the demand of D is satisfied. So we will delete that particular column when we redraw the table. That will be our reduced table in our next step. So now here the capacity remains 15 and this column will be deleted because its demand is satisfied. But if you go for the allocation in this particular, then also it is okay. So if I do allocation over here, then from 15 and 50, the smallest allocation can be 15. So here also you can do allocation, you can check yourself. So this column is now deleted. Now moving to our next step, that is our reduced table, in which this D column will be deleted. So you can see these 4 columns remain, 1, 2, 3, 4, similarly 4 rows, and capacity now of A is 50, that is as it is, but now B remains with capacity of 55. This is 30, that is as it is, and it is 50. So at the same time demand is 25, 35, 105 and 20. Now again calculating the row penalties and column penalties, following the same procedure. For this row, you can see the smallest element is 4 and second smallest is 6. So difference between that will be 2. Similarly for this 10 and 8, the difference will be 2. For here it will be 6. For this column it will be 5, 2, 2, 0. So you can see the row C is having the largest penalty among all the penalties that we had find out. So we will select this row for doing the allocation. Now for this particular row you will have to find the cell with the lowest cost cell. So 14, 4, 10 and 13. So 4 is having the lowest cost cell among other values of that row. So we will select these for doing the allocation. Now the demand is 35 and the capacity is 13. So among 35 and 30, the minimum value is 30. So that's why I have allocated 30 over here. So now you can see this C factory's capacity is exhausted. So we will delete that row when we draw our next table. That will be our reduced table, and still here the demand remains 5. So factory C is exhausted, so it is deleted in the next step, and allocation is done in the row C having the largest penalty in the cell 6, 2 with lowest cost cell. That is what I have explained. So moving to the next step, that is our reduced table. Now you can see the factory C is deleted and now 3 factories remains, A, B and D. Similarly 4 stores remains, but now the capacity is 50, 55 and 50. 25, 5, 105 and 20. That is what I have taken from the previous table. Now again finding the row penalties and of all the rows and column penalties of all the columns. So here you can see there is a tie among the penalties, because this first column is also having 5 penalty and this particular column is also having 5 penalty. So going with which? So there may be a dilemma to go with which column. So you can see in this particular column the lowest cost cell among 9, 13 and 4 is 4. So here the demand is 25 and the supply capacity is 50. So among 25 and 50, the smallest value is 25. So I can do allocation of 25 units. But if you go with this particular column having penalty 5, the smallest element will be 6, the demand is 5 and the capacity is 50. So maximum allocation that you can do among 5 and 50, that is 5. So here you can do only allocation of 5 and here you can do allocation of 25. So when such cases arises, you should go with the allocation in which you can do maximum allocation. You should go with the column in which you can do maximum allocation. Here you can only do 5 allocations, here you can do 25. So we will go with the row or column in which we can do maximum allocation. That's why I have gone with this first column. So I have allocated among 50 and 25 the smallest allocation, that is 25. So now you can see the demand of first store is satisfied, that's why it is 0 over here, and now capacity becomes from 50 to 25. So this will be deleted in our next table, that will be our reduced table in our next step. So column 1 with highest penalty is selected and the lowest cost cell is A1, so allocating 25, and now the demand in column 1 is satisfied, so deleting it. So our reduced table will be like this, in which stores 2, 3 and 4 will be remaining. Similarly factory A, B and D, whose capacities are given at the end of the row, that is 25, 55 and 50. Store 2's demand was 5, which I have written over here, 105 and 20. Now again calculating the penalties of rows and columns. So for the first row A it is 2, for B it is 2 and for the D row it is 3. Similarly for column it is 5, 2 and 0. So the largest penalty among these rows and columns, that is this column is having 5, so I am going with this column to do the allocation. Now the lowest cost cell in this is 6, so the demand is 5 and the capacity is 25. So among 25 and 5, the smallest value is allocated in the lowest cost cell. So 5 is allocated in this particular cell. So you can see now the demand of this second store is satisfied. So we will delete that when we will draw next table. So that will be our reduced table, and now capacity of A becomes 20 from 25 because we have allocated 5 units over there, and at the same time this second store's demand was satisfied, so we will delete that column. Moving to the next slide, allocation is done in the cell A2 and that is equal to 5. So now reduced table will have the third and fourth column, means store remains, that is 3 and 4. Similarly, the supply capacity of A, that will be now 20, for B it is 55 and for D it is 50. Demand is 105 and 20. So now again calculating the penalties of row. So there are only 2 elements, so difference of that will be 5, 2, 5. Again finding the column penalties, here it will be 2 and 0. Now again you can see there is tie among the penalties. Both A row and D row both are having 5. So to go with which row, there may be a question. So if you go with this row, the smallest cost cell is this. So if you do allocation over here, then how much units can be done? How much allocation can be done in this particular unit? So if you see, the demand of third store is 105 and the supply capacity of A store is 20. So maximum allocation that can be done, that is 20. And if you go with this particular row for doing the allocation, then lowest cost cell is also 8 over here. Now among this, demand is 20 and supply capacity is 50. So in this you can go with this row also, or you can go with this row also, but I have opted for this. So among 50 and 20, the smallest value is 20, so I have done the allocation over here. So you can see now store 4's demand was 20 and that is already satisfied by doing the allocation. So this will become 0. So this store will be deleted in our next step and that will be our reduced table. Now you can see the supply capacity of factory D will now become 30. So moving to our next step, allocating in cell D4, it is equal to 20. So delete column 4 in the next step. So our next step will be the reduced table in which this store 4 requirement was satisfied. So we have deleted, now only remains store 3. I have put all the values from the previous table of this third store, 8, 10, 13, demand was 105. Now capacity was A, that was 20, that is as it is. Capacity of B, that is 55, that is as it is, and supply capacity of D, that was 30, which I have put over here. So now doing the allocation among the lowest cost cell in this third store. So 13, 10 and 8, lowest cost cell is 8, so we will do the allocation in this. Now you can see the capacity is 20 and demand is 105. So among 105 and 20, the lowest value is 20. So I have done the allocation over here. So you can see now the capacity of A factory is exhausted, so it is 0. We will delete that in our next step and we will redraw the table. That will be our reduced table. So now remains only factory B and D. This will be the value 10, 13. Demand still of the store 3 is 85, capacities that was of B is 55 and for D it is 30, still it is remaining. So now again doing the allocation among the lowest cost cell, that is 10. So demand is 85 and capacity is 55. So lowest among 85 and 55 is 55. So I have done the allocation of 55 in this particular cell. So now you can see factory B's capacity is now exhausted, so it will become 0. So deleting that row, now only one factory will remain with supply capacity of 30 and store 3's requirement is also 30. So allocating 30 over here. So now all the factories capacities are exhausted and the demand of each stores are satisfied. So we will stop doing the allocation process. So allocating in the cell B3 55 and now remaining 30 in the cell D3 over here. So all the capacities are exhausted of all the factories and demand is satisfied of all the stores. So now I am drawing again the main table. Now this all the values that we had obtained during the various steps, so all the allocations are put in this main table wherever we had done the allocation, and now we are finding out the total transportation cost. These cells in which we are doing the allocation, this cell is called occupied cell, and the cells in which there is no allocation, those cells are called unoccupied cells. So finding out the total transportation cost, these values shown rounded or inside the circle, that is called Xij, number of units that can be transported from ith source to jth destination. And this outside or without any circle, these values are called Cij, unit transportation cost from ith source to jth destination. So if you find out, then it is 1510. So this is the total transportation cost that we had obtained using WARM method. So now checking whether this problem is having a basic feasible solution or not. So the problem to have a basic feasible solution, it must have m plus n minus 1 allocation. So m is number of rows and n is number of columns. So 4 plus 4, that is 8 minus 1, 7. So you can see the allocations. Sorry, there are 4 rows and 5 columns. So 4 plus 5, 9 minus 1, 8. So you can see there are 8 allocations, 1, 2, 3, 4, 5, 6, 7 and 8. So this problem is said to have a basic feasible solution. Moving to our next slide. Now performing optimality test. So what is the procedure? Now we will have to find out optimal solution for the given problem. So for that, what is the condition? Number of occupied cells should be equal to m plus n minus 1. So that is equal to 8. So we can say that we can perform the optimality test. Number of occupied cells should be equal to m plus n minus 1. So if you put the values here over here, it is equal to 8, and you can see from the previous table that there are 8 allocations. So now you can perform the optimality test. So for that, we had also seen one method to obtain the optimality test, and that was Modi method. So that method we will follow over here to obtain the optimal solution. So determining ui and vj of the rows and columns. So ui, that is general term. For rows, there are 4 rows, so I have written I is equal to 1 to 4, and for column there are 5 columns, so vj, j is equal to 1 to 5. Now assuming any one value equal to 0 and finding out the other values. So for occupied cell, the relationship that is used to obtain the values of ui and vj, that is over here, that is given in equation x. So the general equation or the relationship that is used to find, that is Cij is equal to ui plus vj. This is the general equation, and I am naming it as an equation x. So now all the occupied cells, that is written over here, C11 is equal to U1 plus V1 is equal to 4. So C11 is this, means this value, unit cost of transportation of the occupied cell. Similarly for the occupied cell C12, the unit cost is 6, so it is U1 plus V2 is equal to 6. Similarly for this cell C13, it is U1 plus V3 is equal to 8. Similarly C23 is equal to U2 plus V3 is equal to 10. C25 is equal to U2 plus V5 is equal to 0. For this occupied cell, it is C32 is equal to U3 plus V2 is equal to 4. C43 is equal to U4 plus V3 is equal to 13, and C44 is equal to U4 plus V4 is equal to 8. Moving to the next slide. Now, as discussed in our previous slide, we will take any one variable equal to 0 and we will find all the other values of ui and vj. I have assumed u1 is equal to 0. You can assume any value equal to 0. There is no any specific rule, but you will have to assume any one variable equal to 0 so that you can find other variables. So u1 plus v1 is equal to 4. So I have assumed u1 is equal to 0. So you can get the value of v1 is equal to now 4. Similarly, in this case, u1 plus v2 is equal to 6. u1 is 0, that is assumed. So you can get the value of v2. Similarly, u1 plus v3, so you can get the value of v3. Now u2 plus V3 is equal to 10. So U2 plus V3 is equal to 10. So V3's value is 8. So I have put over here. So when it goes to the right hand side, so it will become 10 minus 8. So U2 is equal to 2. Similarly, U2 plus V5 is equal to 0. So U2's value you have obtained over here, that is 2. When it goes to the right side, it becomes minus. So V5 is equal to 0 minus 2. So it is minus 2. Similarly, U3 plus V2 is equal to 4. So putting the value of V3 that was obtained over here, V2's value that you had obtained, U3 plus V2 is equal to 4. So here you have obtained the value of V2. So put over here, that is 6. So 6, when it goes to the right hand side, it becomes minus. So 4 minus 6 is equal to minus 2. Similarly, this value is found out and this value is found out in the same way. Now next step, calculating the opportunity cost for all the unoccupied cells. So there are many unoccupied cells within the solution, within the table, the main table that we had seen the last. So how to calculate the opportunity cost for all the unoccupied cell? So this is the formula, that is delta ij is equal to Cij minus, in the bracket it is ui plus vj. Name this is equation y. So now calculating for this unoccupied cell delta 14, C14 minus inside bracket u1 plus v4. So this C14 that can be obtained from the unoccupied cell cost, that is 13, minus the values that you had find out of u1 and v4, that will be now substituted over here. So that is equal to 10. C15, that is 0 minus u1, you had assumed 0 and v5's value was minus 2. So 0 minus 2, it will give plus 2. Similarly, all the unoccupied cells opportunity cost is calculated in the same way, where you will have to substitute all the values of u1 and v1, and these values can be obtained from the unoccupied cell. Moving to the next slide. Similarly for this, so now you can see here it is an minus 3 value. So what is the condition to obtain the optimal solution, or when you can know, okay, you have reached the optimal solution for the given transportation problem? So that condition is nothing but the opportunity cost that you are finding out for all the unoccupied cells, that all unoccupied cells must have either 0 value or positive value. Then you can say, okay, you have reached the optimal solution for the given transportation problem. But you can see over here in our previous slide, here all the values are plus, here all are plus, but this one unoccupied cell, that is delta 45, is having negative value, and that is minus 3. So now you can say, okay, we have not reached till the optimal solution for the given problem. So now what to do? So there is a procedure to obtain the optimal solution. You will have to draw a loop for that, but there is a positive thing in that, okay, when the unoccupied cell is having negative value, so that will make our solution more with the reduced transportation cost. So you can say, as the unoccupied cell is having no negative opportunity cost, so now drawing the loop. So now there will be reallocating that will be done when you are trying to solve this. Now the unoccupied cell, our main task will be that this unoccupied cell will be converted into occupied cell, such that the reallocation will be done, and we will get, there are chances of now the reduction in the total transportation cost. Our main aim is to include this unoccupied cell convert this unoccupied cell into occupied cell, such that by doing reallocation, and that will be obtained by drawing the loop. So I have drawn the loop over here. So what is the procedure to draw the loop now? That is explained over here. This is all the values that I have written, that is as it is. Now all the unoccupied cells value delta ij is written inside the box, inside this rectangle. So you can see this unoccupied cell value, that is 10, that is put inside this box. For this unoccupied cell it is 2, for this it is 7, for this it is 3, for this it is 3, for this unoccupied cell it is 12, for this it is 4, 0, 0, 0, and this is minus 3. This is better explained in our next slide. I have drawn this same table in next slide for your better understanding. So this is the same table of the previous slide which I have drawn. All the values of unoccupied cell is shown inside this rectangle. So for this it is 10, for this it is 2, for this it is 7, for this it is 3, for this it is 3, for this it is 12, it is 4, 12, 4, 0, 0 and 13. These all are the occupied cells. Those values I have written as it is. Now you can see in this cell we are having negative value of the opportunity cost. So as we see, cell DD is having negative value in the unoccupied cell, so our loop will start and end at that cell. So we will start drawing the loop from that particular cell. So right angle, certain rules are there. Right angle turn is in this loop or path is permitted only at the occupied cells and the original unoccupied cell. So right angle turn in the loop is permitted only at the occupied cells and at the original unoccupied cell. Every closed loop must have even number of turns and is formed by horizontal and vertical lines only. Main aim is to convert unoccupied cell to the occupied cell. So this unoccupied cell we will try to convert it into occupied cell. So that will be your starting point of the loop and end point of the loop. So this is your starting point. So that value will be signed with positive sign over here, and then you will have to alter the signs in the loop. So loop is always drawn till this vertical line will be extended to this occupied cell, because as per the rule right turn in the loop is permitted only at the occupied cells. So I have started the loop from drawing from this point, and I have extended it to the occupied cell, because we can only take right angle turn from the occupied cell. So here I have taken positive sign. Now I will have to alter the sign, so it is minus over here. I have taken right turn from here and it is extended till the occupied cell, because only right turn is permitted from here. So here the sign is altered from minus to it becomes plus. Again right turn is taken and it is extended till the occupied cell, because right angle turn is only permitted from the occupied cell. So now again the sign is altered from plus, it becomes now minus. So now there is one occupied cell in between, so I am bypassing it. You can bypass any number of occupied cells. So I have bypassed and I have reached the starting point of the loop. So my loop is now ended over here. This alter sign of plus and minus, here starting point will have plus, then minus, then again altering plus, again altering minus. I have bypassed, so there is no requirement of, it is not of our requirement, that's why I have bypassed it, and I have ended the loop over the point from where I have started. So this is our loop, closed loop. Each and every corner points must have occupied cell for the given path or the loop. So you can see end points of the line must have occupied cell. Here it is occupied cell, here it is occupied cell, here it is occupied cell. So now moving to the next step. Now what are the things after drawing the loop? What are the changes that can be done? So now among this loop, the allocation cell with the lowest value, there are 3 allocation. This is bypassed, so we not need to consider that. So there are 3 allocations, 55, 15 and 30. So among all these 3 allocations, the lowest value is 15. So that will be added where the sign is positive, and that will be subtracted from the cell where the sign is, that lowest value is 15 among the allocation of this 15, 55 and 30. So that 15 value will be added in the loop where you find out the plus sign, and where you find out the minus sign in the loop, that 15 value will be subtracted. So here it will be 15, so this now unoccupied cell will become occupied cell. Here it will become 0, here it will become plus 15, so it will become 70, and here out of 30 that 15 value will be subtracted. So here it will become 15. So that can be shown in our next slide, you can find out. So now the reduced table is like this. This is all the values that I had written. Now the cells which was in loop, here it was 15, so that is subtracted. This unoccupied cell now becomes occupied cell.
so it becomes 15. Here it was 55, so the value in our path with plus sign there, that 15 value will be added, so 55 plus 15, that is 70. Here it was 30, but the sign was minus, so we will subtract that 15 from that 30, so now allocation is 15. So after reallocating, you can see now among the corner points of the closed loop, the smallest allocated occupied cell was 15, so that I have already added and subtracted where the sign was positive in the loop and where the sign was negative. From that I have subtracted this occupied cell, that is 15. Add to cell B3, so in B3 that 15 value was added and it was also added in the cell DD, and subtracting from the cell BD, so it was this, actually it was 15 but we had subtracted, so now it becomes 0, and subtracting from the cell D3, that was this, here it was 30, we had subtracted 15, so now reallocating, after that it becomes 15. So now the optimal solution is reached, because that I have not mentioned over here, but if you check yourself when you will get optimal solution, so after this all the procedure you will have to again calculate the opportunity cost for all the unoccupied cell, for this, this. Now this cell will not be included because it is converted into occupied cell. Initially it was unoccupied cell. So now if you calculate the opportunity cost for all these unoccupied cell, you will find that all the values will be either 0 or positive. So you can say now that I have not shown over here, but you can try yourself. So now the optimal solution is reached as all the unoccupied cell is either 0 or positive. So when you find out the total transportation cost now, so you can say that it is now 1465. So which is less as compared to which you had obtained in your previous using WAM method. That was the total transportation cost that you had obtained. So this is all about this unbalanced transportation problem. Thank you.